Okay, we want to find the equation of the tangent to this function at the point x equals 2. So we go back over the things that we know. What do we need to find the equation of a tangent? We need the slope, we need the point. Okay, we know we're going to get the slope from the derivative of this, but let's get the point first because we've only got our x value. So to get the y value, it's a simple case of substituting into here. So our x value is 2. When I put 2 in here, I get e to the minus 2. So we've got our point. The slope, as we said before, is going to come from the derivative. So the derivative of our function here, remember to differentiate e to a function, we write e to the function down, so e to the minus x, and then we have to multiply by the derivative of what's up here. Now the derivative of minus x is just minus 1. So I'm going to times by minus 1 and just cheat a little bit and put it out the front. Okay, now at x equals 2, our slope, aka the derivative, will be minus e to the minus 2. We can tidy it up to make our life easier to be minus 1 over e squared. Okay, so we check that we're getting the tangent and not the normal. Obviously, if we wanted the normal, we would get the negative reciprocal, so turn this over and make it positive e squared. But for us, we are getting the tangent, so there's our slope, and our point is 2 e to the minus 2, and away we go using our normal slope formula. So it'll be y minus e to the minus 2 all over x take 2. Cross multiply, minus 1 times x gives me minus x plus 2 equals e squared times y. Now e squared times e to the minus 2, think about that. That's e squared times 1 over e squared. It's like saying 4 times a quarter. They cancel. I'm left with just 1. So we get 1 there. You can decide now, do you want to put in general form or y-intercept form? So if we go into general form, the x goes on the other side. So that'll be x plus e squared y. Minus 1 joins the 2, so it becomes plus 3, so it's 3 equals, which is the same as that, equals 3. So you can have it like that, or you could pop this in the y-intercept form, and so we get y by itself, so that'll be the x is over the other side, so it becomes minus x, I'm dividing by e squared plus 3 over e squared. So whichever one you want, but it's the same thing that we've been doing before. Okay, equation of tangent, get the slope, get the point, off you go. Okay, so let's try one now with an ln, and really the only difference is you realize that x has a value here that we can't, well, it has a limit on the value because we know we can't ln 0 or negative. So if we look at this, we know that x must be greater than 2. Okay, because 2 take x, sorry, less than 2, because we know that 2 minus x has to be greater than 0. So the x goes on the other side, or the minus 2, the 2 can go on the other side, because minus 2, to get rid of the minus, you reverse that sign like so. So you don't have to write that, but we just keep that at the back of our mind so we know that those are the values of x that we're dealing with. So we do the same thing that we did before. We're going to get our point, because again, to find the equation of tangent, you need a point and a slope. We pop our x here is minus 1, we put minus 1 in here, so 2 take 1, it becomes ln 3. We leave it as exact. Okay, we now want to get our slope, so dy by dx. Remembering that to differentiate ln of a function, it's the derivative of the function divided by this function itself. So the derivative of 2 minus x is minus 1, and we divide that by the function to take x. Now we're going to slap in x equals minus 1. So at x equals minus 1, our slope of the tangent is going to be minus 1 over 3. We've now got our slope, we've got our point. The only difference from what we were doing previously is that we're dealing with ln's here. Remember, that's just a long-winded number, which we like to just abbreviate to ln3. So away we go. Minus 1 over 3 equals y take ln3 over x take 1. So we've got x plus 1. We'll cross multiply. Minus x take 1 equals 3y minus 3 ln3. Now it's up to you. You can keep that as 3 ln3, but I hope you also know if anyone writes it as ln27, we know that's because this 3 comes upstairs like so, and 3 cubed is indeed 27. So, you know, be comfortable with how we write these things. So we can pop this, again, we can pop that in general form if we wanted to. So the 3 ln would be like so. Take 1 equals x plus 3y. And I like to have it like this, so we'll just 3 ln 3 take 1. And if you wanted it in the y-intercept form, that's the y by itself. So we will have y equals, it'll be 1/3 x minus thereof, because you're putting the x on the other side, plus ln3 divided by 3 ln3 divided by 3 is ln3 take 1/3. So whichever way you want to see it, that's fine. So nothing that extraordinary when we're dealing with e's and ln's. Just make sure that when you've got the function that you're differentiating, if it's a function times a function, then use your product rule. If it's a function divided by a function, go the quotient rule, and of course look out for that chain rule.